Hi there, and welcome to our last episode in our C2 chemical resources topic. And today we're going to be looking at the electrolysis of sodium chloride, which is one of the chemicals from the sea. Anyway, I hope you enjoy it, and I will see you later. Bye-bye. Okay, so our objectives for today. For the end of this lesson, you should understand how sodium chloride is split during the electrolysis of brine. It's just important to understand that brine is saturated salt solution. Salt, which has the chemical name of sodium chloride, has several uses. The most obvious use that you're probably familiar with is flavourings for things like fish and chips and other foods, and for preservatives. But it's also used as a raw material for the chemical industry. Now, in the UK, salt can be obtained from seawater. As we're an island, we're surrounded by it, but it can also be mined from solid rock salt. Now, the rock salt is used for gritting roads, but as we said, it can be prepared for the chemical industry. Now, the way it's prepared is via a process called electrolysis, which we have looked at earlier in the topic when we looked at the extraction of copper, and it is a very, very similar process, but at the same time it appears to be a lot different. Okay, now with the electrolysis of sodium chloride, we have a setup like this here. Now, I'll just run through a few parts of it. At the bottom here, we have the anode, which is the positive of the two electrodes. Now, on this side, we have the cathode, which is the negative part of the negative electrode. Now, entering through here, we have sodium chloride solution, and then in here we have what we call a membrane. Now, a membrane here, it stops some things from going across here, so you will have some things coming across, but others will stay where they are. Now, what will happen is from the anode, we will actually have something given out here. This is a gas which is chlorine gas, which means that on this side we have something else that's given out. Here. Again, this is a gas, but this time it is hydrogen gas that comes out. We also have a third product from here, which is able to come out the bottom. Let's change that arrow. Let's make it the same as the others, red. Okay, so we have something coming out of the bottom here, which is sodium hydroxide. Now, there are several uses for the products. Now, we have three main products. These are hydrogen, chlorine, and sodium hydroxide, which we have just seen in the previous section. Now, the uses that they have include margarine production for hydrogen. For chlorine, they're used to sterilise water, for making solvents, and for plastics, such as PVC. And then finally, sodium hydroxide is finally used to produce soap. Now, you can actually take the chlorine and the sodium hydroxide together, and they are used to produce household bleach. Now, in order to test which one is the anode and the cathode, you can test for where the chlorine gas is. Now you can see here you've got moist blue litmus paper, which means this is an alkali to start with. Now if you've got the chlorine gas being released, it will bleach the litmus paper here, so it'll end up going a white colour as opposed to the red that you'd expect for an acid. Now when we have a look at the reaction vessel where we get the electrolysis actually occurring, we have got here a solution, and we have the sodium chloride coming in, the chlorine coming out, the hydrogen coming out, and the sodium hydroxide coming out, and then we have our membrane in the middle here. Let's draw that in here. Now within there what we have is we have a whole series of ions. Now ions are charged particles that you might be able to remember from when we did the electrolysis of copper. Now with the sodium and chlorine, or sodium chloride, we have Na and we have Cl. Now you'll notice that we've got the positive charge on the sodium and the negative charge on the chlorine there. Now as well as having those two, don't want to do that, as well as having those two in there, we've also got water, which contains two ions, an hydrogen ion and an hydroxide ion. So we've got a H plus ion and a hydroxide ion, and you'll see there that the water is H2O. So water splits into two down the middle with one H and an OH. Now you'll possibly notice that the chlorine ion here, actually chlorine comes out of the top here and hydrogen comes out of the top here, and that means that we have sodium and the hydroxide which come out here. Now the sodium and the hydroxide just stay as they are, which means these we don't need anymore. There's no further reaction with those, but the chlorine here and the hydrogen actually undergo a redox reaction. Now if we have a look, first of all we'll look at the chlorine. Now we start with the chloride ions here. Now what these chloride ions do is they lose two electrons and they end up becoming a chlorine molecule or chlorine gas. Now this is an example of oxidation. Now on the other side we have the hydrogen being formed. Now you can see the hydrogen there, which is positive, it actually gains the two electrons. You'll notice two electrons are lost there and they are gained here, and that becomes hydrogen 2. Now this is an example of reduction. Now as we said, the sodium and hydroxide, they form sodium hydroxide, and they're taken off for various other different things as a solution. Okay, so we have looked at the electrolysis of sodium chloride, where we make three products. We make chlorine gas, we make hydrogen gas, and we make sodium hydroxide. So we can see that the ions involved, the sodium ion, the chloride ion, and the hydroxide and hydrogen ions from water, they are all used in that reaction. We've also looked at the test for the chlorine gas, which is the use of moist litmus paper, and we've looked at the redox reactions that are involved. Anyway, that is the end of our whole C2 topic on chemical resources, and we'll have a revision session next time, and after that we will do the end of unit test. Anyway, I hope you enjoyed it, and I'll see you again soon. Bye bye.